Kaplan turbine, that is penstock, scroll casing, or everything has been provided here, along with the specifications and the operation and maintenance of this particular turbine. So, and also the differences between reaction and impulse turbine. So, we all know that Kaplan is a reaction turbine. So, and the working proportions of Kaplan turbine is also been displayed. So, we can go through this. I guess you can go through all this later. Once we go through theory, we directly have something called pretest. So, if anyone could answer me the first question, that is Kaplan turbine is preferred a head range of any answers, that is A is 0 to 25 meter, 25 to 100, 50 to 200, 0 to 100. So you have 4 options. Any answers from the participants for the first question?
0 to 25 meters.
Okay. Okay, thank you. So if I directly submit my quiz, the answer you have answered is right. So it is 0 to 25. So whatever I have not answered will give an error. So this is about self, that is pretest. Once the student performs this, he can go to procedure. For now, I know how to carry out my simulation, so I'll not go through this. I can directly proceed with simulation. So if we forget like what is the next step, you can use this option called pop-up procedure, where you will be guided to carry out the simulation. So once that is done, you can see the objective has been displayed, that is to conduct performance test on Kaplan turbine under constant and to plot the operating characteristics. So this is our objective. And the apparatus used has been displayed, that is Kaplan turbine setup with centrifugal pump, the spring balance with weights and other things. So here you can see there is a different description. So what is this description is, you have the important terms used in this particular experiment displayed. So before conducting this experiment, a student can go through these and understand the basic definitions of what is reaction turbine maybe, or what is actual turbine. Once we go through this, we'll have a clear picture on this Kaplan turbine. We have the setup being displayed here. Directly click on next button. So first step is to start the pump by pressing start button, and I start the pump. So here we know that it is constant head. So initially we select the head and maintain it to be constant. I'll select a head of 5.5 meter. I click on OK. So you can see here we have something called formative questions being displayed here. This is basically done in order to engage the student throughout the simulation. So I need the answers. What is Okay, so any answers from the participants? What is Kaplan turbine is also known as? Okay, propeller. I got an answer saying propeller turbine, so I'll just click on that. Yeah, the answer is right, so we can proceed. Initially, in the previous step, we selected a head of 5.5 meters. So our step now is to set that head. So we have selected the head as 5.5, and that is set here. So we all know that initially there will be empty weight. So the torque calculation has been displayed here. So using this formula, we can directly calculate the torque values. For now, I will be entering a random value, and then the result will be displayed. If your answer is wrong, the result will be displayed, or else you can directly enter the right values. It is always better to calculate and enter the values. So now tachometer is inserted in order to measure the speed. So once we know the speed, we release the notch in order to identify our initial reading and then the final reading, and then obtain actual discharge value. So we can see here the discharge value, value to be calculated, has been displayed, and also the variables used in this particular calculation, that is CD and the length of the wire, has been displayed, so that we don't have any difficulties in calculation. So now I'll directly enter a value and then obtain the results. So this was about actual discharge calculation. Once we obtain the discharge value, you'll directly proceed with the observation and then the result. So we have one more question here, that is constant head. So what was the constant head we have set in the first step? Any answers from the participants?
5.5.
Yeah, thank you. So 5.5 was the answer set. So this basically engages the student towards the simulation so that he concentrates on what is happening in the simulation. So we can see here, our next step is to calculate the output power. So we have the formula for input power, the output power, the efficiency, unit power. So for now, I'll directly enter our random value and then proceed with the results. Even here, we have entered the data set from the conventional lab, so we can see the results close by to our results which is obtained from conventional lab. So this was about one of the experiments in fluid machinery lab. So now if I click on next button, similarly I have set of trials which I would prefer for now I'll stop this, and if any of the participants is interested in presenting in any of the experiment, they can come up. Any participants in the same lab, the other experiments, I want some of the participants to share their screen and then present it. Anyone?
I will present.
Yes, thank you. So I'll stop sharing right now. So you can share your screen and present.
Can you see my screen, ma'am?
Yeah, we can see your screen.
Yeah, I'll go with the Pelton wind turbine.
Okay.
Yeah, should I go directly to simulation, ma'am?
Yeah, you can go directly to simulation. So here you can see there is two conditions, that is constant head and constant speed. You can select either of them and then proceed.
I'll go with constant head.
Yeah.
So the description part, it will give the details of the experiment, right, ma'am? So some definitions.
Yeah, some definition on like impulse turbine, reaction turbine, what is crosshead and what is nethead. So all these important terms are being defined here.
No, I should go to next.
Yeah.
Start
So
the
initially
pump.
you need to start the pump. Yeah.
Select the constant head.
Yeah.
Anything I can select, right, ma'am?
Yeah, you can select either of them.
Yeah, okay.
Okay. Click on next button.
Now the
So
pressure.
you need to rotate the inlet valve in order to obtain constant pressure and head. Click on that.
Yeah, it's done.
Okay. Okay. So
Next
you need next button. So here initially it will be dead weight. So
Yeah.
the formula will be displayed for torque. We can calculate. For now, you can enter the value.
So any value, ma'am?
Yeah. It is always better if you calculate and add, but for now you can enter the value, like random value, and check. And then click on check button again. You'll have the result tab. You can click on that to display the result. Okay, this is your result. You can click on next button.
Yeah.
So the speed of motor has been displayed here.
That is, 960.
Yeah, 960. Yeah. So you can click on next button.
Yeah, now
So you need to calculate the discharge here now. So you can release the valve. Yeah. So directly you can calculate the discharge. Yeah.
Should I click check or enter some value, ma'am?
You need to enter some value and then click on check.
Okay.
Yeah. You have the discharge value displayed. You can click on next button. So here you have a question. You can answer that.
18.
That is, what is the constant head you have set?
Declined is two cases were declined. One was a lab instructor. And
Input
one
power,
was a
I will enter some value.
Anyone told like
Okay.
we'll have only faculty.
Result, yeah.
Yeah.
So similarly, you can calculate output power, efficiency, unit power, unit speed, and unit
It's
discharge.
okay. You can tell him that.
For all, we need to enter the values, right, ma'am?
We can
Yeah, it is always better you ask the students to calculate the value and then enter so that they get the right values.
One lab instructor was there and one research scholar was there. Oh, okay.
Now next button, right?
Yeah.
Ma'am,
Yeah.
How we able to plot operating characteristic curves on constant rate and constant speed based on these results?
Yeah, if you proceed with all the trials, finally there is an option to plot the operating characteristics. I guess the person who is presenting now, that is Sachin sir, you can
Yeah.
proceed with the trial so that you can show the participants how do you get the operating characteristics.
VTU will not work.
This is
Okay,
trial
thank you.
two.
Okay. Yeah, it's streaming also. You can just do one thing. You can just keep an eye on the streaming because the streaming has a tendency to get disconnected a lot of times.
Answer,
You
please.
can keep an
Yeah.
eye on it. It gets disconnected or
You can
something.
ask
Just put me a
participants.
message.
Anyone can answer?
Yeah. It's actually you can go directly to CSD YouTube channel. There you'll find it. Okay.
Pelton turbo is a type of?
Yeah. Okay.
Any answers from the participants?
You can keep typing it in the chat box.
Impulse turbine.
Okay. Alright. Next. Trial 2. Give the speed of motor. It's 910 RPM.
Yeah,
Now I need to
you need to release the water and then you'll have final reading being displayed in order to obtain the discharge value.
head water is calculated by?
Participants can answer in the chat box. Any answers from the participants?
Four options.
Yeah. The next question is being asked there, that is head of water is calculated using. So the formula is displayed, you can answer.
We can select it, right, ma'am?
Yeah, you can select any of the options and then proceed.
Here we need to give the
Values and then click on results in order to obtain the correct results.
yeah. Okay, now
Yeah.
this is
So you have 4 trials here.
yeah,
So you're adding the weight
yeah.
and then again torque value has been calculated.
That's fine. And the answers are earlier they are calculated the answers, right, ma'am?
Yeah, all these data sets, whatever answers you're getting, that is the answers obtained from conventional labs of NITK. So all the data has been fed directly into the simulator. So we get the real-time data itself. All observation and calculation. So you can click and stop the pump. You click on next button, you will have a note saying trial has been carried. Because in our conventional lab we have around 8 trials has been carried out. But then here we have not given since it would be a repetitive process. So we can click on this button in order to obtain the characteristic curves. So if you click on efficiency versus unit speed, you have the graph being displayed for efficiency versus unit speed. So if you click on the points over there, you'll have the values being displayed.
Just if you place the cursor, we will get the answer, ma'am.
Yeah.
We are not supposed to click. If you just place the cursor on the points, you'll get the answers.
Yeah. So I guess I've answered one of the question about characteristics curves here.
No need to click. Just place the cursor on the points. We'll get the answers.
Yes. So similarly, there is graph for unit power versus unit speed, unit discharge versus unit speed. So all these three characteristic curves are plotted.
Can I stop sharing the screen?
Yeah, you can stop sharing.
Thank you.
Yeah. There was a question about CAD lab. So right now there is no labs related to AutoCAD. So that was one of the gap areas in the coming time. And regarding surveying, there is a lab developed by IIT Hyderabad or Kanpur, I guess. But then that lab is under maintenance. So you can go through the simulation in an audio base, like there is a video of that particular simulator, but then you can't perform the simulation. So that is, you can directly contact you can directly contact vlab.co. So maybe you can write a mail to them and they'll rectify it. So that lab is under development. And one more question is about concrete lab. Yeah, we have a lab related to concrete lab, which will be demonstrating it in the coming time. That is marine structures lab developed by NITK, consists of experiments related to concrete lab, that is your slump test and so on. Regarding geotechnical lab, yeah, we are developing GT lab, but then it is not yet in the main site. Very soon you can see that lab in blabs.co.in. So if I've answered all the questions, I guess we can proceed with the next lab. Yeah, there's one more question regarding engineering geology lab. Yeah, we have developed by NITK, that is mining geology. You can see it in blab.co.in under civil engineering. So I guess we will be demonstrating all these labs in our coming session. So for now, I'll be handing over my session to my colleague, Aishwarya Hegde. So she'll be taking you through the other labs. So there is one more question whether these are linked. Yeah. For now, we have video demonstration, that is Lagu Pata, which will be explained later at the coming session. We have video linked to that particular experiment, that is SOM and FM lab. We have the video demonstrations for that. So how to create the experiment in virtual lab? I guess KVP sir would answer this question. For now, surveying lab is under maintenance, so I can just show the video demonstration of that particular lab, but you don't have simulation in that. So that lab is okay, so okay, someone asked me to demonstrate surveying lab. I'll just share the screen. It's visible and I'm audible.
Yes, ma'am. Yes.
Yeah. So this was about surveying lab. So you can see the same template has been followed here as well. You have the introduction regarding this particular lab, the list of experiments. So if you click on any one of the experiment, that is, for example, the basic experiment, that is various parts of auto level, you have the objective. So this is very simple experiment. So the various parts has been displayed here, and you have the audio also, like what is this particular part. So this is a kind of simulation that has been developed. So every part of the auto level has been displayed here with the definitions of that particular part. So this was one of the experiment on surveying lab. Similarly, you have other set of experiments. You can go through that. So if you go to the second experiment, that is carry out fly leveling. So if we click on experiment, so you have something called download executable file. If you download this, and then you can directly proceed with the simulation. So it will allow you to carry out the simulation. You'll have a zip file being downloaded, and then you can open that and carry out the simulation. So you can click on procedure to understand how to carry out this particular experiment. So this was about survey lab. So I'll stop sharing right now since it's already 12:30. So 12:30 we had to end the session, and we'll be meeting back again at 2:30, I guess. So there is no, for now, there is no lab developed under CAD, that is computer aided design of structures. That is a gap area. So I guess once that is filled, we'll be having a lab on that as well. The next session will be starting at 2:30. So if there is no other,
The next session starts at 2.
okay, it starts at 2. Sorry.
Yeah. So 2 to 3 will be the demonstration. 2 to 3:30 will be the demonstration, followed by a session by Prithviraj sir.
Should we leave or should we stay in the meeting?
Are we supposed to stay in the meeting or we need to leave the meeting now?
Sir, you can leave the meeting and join back in the same URL at 2 o'clock.
2 o'clock. Okay, now we can leave the meeting, right?
Yes. So please ensure everybody joins by 2. So
Yes.
in morning session we have already been delayed.
Yeah.
So all the participants requesting everyone to be joining the session by 2.
We are supposed to join by the same link, right? The
Yes,
one
sir.
we are using. Okay, ma'am. Okay, ma'am. Thank you.
Yeah, thank you, ma'am.
And the session recordings will be shared to every participant. So that was one of the questions from Mahadevi. Okay, so I guess we can leave the meeting right now and come back again at 2 and with the same link. Thank you.